what I will do, I will send the same link to the Blackboard as well. Because I thought that was faster. What you have there are, okay, do I have them here?
Doctor, and regard the exam day.
We have already finalized something, don't go back to it. Okay. Hang on.
What is the final?
So what you see is that's actually one of the students from the voice group. He has a Dropbox account, so he volunteered. I was showing them this file. Each file is quite big. You can see some almost 400 megabytes for each folder. Each folder represents the data, EEG data for one patient. First patient, second patient, third patient. So it is taken from a list of 29 patients. That's why you can see 1, 3, 14, 18, 20. I have selected only those patients that have lots of seizures in their files. Each one of them have at least 7 or 6 seizures in the whole of the recording. What's inside each one of them is a folder which has recordings from different probes where the seizure is seen. Each one of them is also quite big file, by the way. When you load it and you try to work on it, it is going to be very waiting time. You have to be really very patient before you get results out. It's very, very long files. Okay? But what do you have to do in the project? Let's talk about it. What you have are files and a summary in the end. Each folder has these files which are let's say chb01_03.mat file. So you know what mat file is? What is that? MATLAB file? So what is the difference between M file and mat file?
We know .m.
.m file is MATLAB file. What is .mat file? It's a matrix. It's just data. Okay, it's stored in a way that it represents some kind of a matrix. And when you open it, you will see that it will have 23 rows and several columns.
We open a notepad?
No. Open it in MATLAB. So how do you open a mat file in MATLAB? Just load. So load chb01-03. Don't have to put .mat in. It will load it, but it will load it with this name. There's another way. If you don't want to put this name, you can say x equal to load, and within parentheses put the file name in chb01_03.mat. Like this. This will store the data in X directly, and then you can use this X wherever you want. Now, what do you expect in this one? So you'll get data, and then somewhere seizure, and then something else, maybe another seizure, etc. How do you know which one is which? It's really, the data will be like kachara, just like this, full of garbage. You don't understand. It's really very hard to work with EEG signals. But I told you the importance of EEG signals in one of the previous classes. So for your training or building or development of the algorithm, we also have this summary for you. The whole of all the files are actually sampled at 256 Hz. What does that mean? How many samples per second? Sampling frequency, data sampling rate is 256 Hz. How many samples per second? 256 samples per second. So what you are getting, so that's why the size of data is really, really huge. Why? Look at this. You start from here. The first file that you are seeing is chb01_03. It says .edf, but we have already converted it to .mat. So don't worry about this extension. This file is actually a true recording of a patient which started at 13:43 and ended at 14:43. 1 hour of recording. How many samples will be there? A lot. So how many seconds are there in 1 hour?
No.
Seconds, 3,600 times 256. That will be the length of the data sample that you have. Now in this one, you don't have to worry about these times. Okay, don't worry about it. When you load it, it's just a data set pool starting from this starting time and this ending time. Based on this, you can calculate the time vector, and the time vector says that as the system starts working at 2,996 seconds, the seizure starts, and the seizure finishes at 3036 seconds. So it's about 40-second seizure that appears here. So you know the exact location of seizure on the waveform. Okay. This is true for all the files that have. Each file has only one seizure in it, and you know where it starts and where it ends. You are given this. Okay. This is for you to develop your algorithm. But once the algorithm is developed, we just apply it and see if it's really detecting the things correctly or not. Okay. So how do we develop this algorithm now? I ran out of time, but let's quickly. Let's say this is the seizure part. Seizure, no seizure, no seizure. You have studied so far, the techniques that we have covered are FFT, DWT. Oh, another interesting thing I saw in one of the solutions, somebody used the function DFT. I don't know where it came from, but in the exam, somebody used DFT as a function, which didn't work as well. So FFT, DWT, what else have you used? FFT and DWT and the filters. FDA tool, right? You have these three functions to play with for the project. First thing you can do, look at the frequency components of this part, frequency components of this part. Do you find any difference? If you do, how can you detect it? Can you design a filter based on that? So that when a signal passes through this filter, if it gives you high amplitude, it means there's a seizure. It doesn't give you high amplitude, it means no seizure. One possibility. You can use DWT to indicate if there is a seizure part, it will have high noise content. So you look at, remember we had the XA and XD approximation and the detailed component. When seizure comes in, detailed component become high in energy. So you can take the signal, give it to the two the WT wavelet transform signals. So this is XA and this is XD. You can calculate energy here and energy here. If the energy in the detail is high, that can be a seizure point. So
High and what?
there are different possibilities. You can come up with different techniques, different combination of these three only to come up with one algorithm that, if I use it with any other file of the same patient, should be able to give me the seizure at least with some accuracy. You will work on? No. Okay. Good question. Select any two files. Any two, one for testing and one for training and one for testing. Okay. So we'll see if it's working for both patients or not. At least it should work for one patient. So you have these 5 files in that link. Choose any two. They are all equally good in terms of detection. The detection is quite easy in these files. Those that have difficult seizures, we have already removed them. These are very simple seizures. Say that again? 2 patients, any 2 patients. Out of these 5, inside each one of them, I showed you here, let's say 20. It has 1, 2, 3, 4, 5, 6 different recordings of the same patient. So now, using this one, these 5 or 6, or some of them have 7, some of them have 6, so it depends on how many seizures they have. Each file has a seizure. You can use any number of these to come up with your algorithm. So look at the frequency components in any one file, second file, third file, fourth file, fifth file, to see what are the frequencies that are in normal state, what are the frequencies in the seizure state. Design a filter based on that, you have your algorithm ready. Then test the same algorithm on the second patient that you have selected and how accurate is that. That's all. Okay, how do you like to write your report? Okay, so for this we have a deadline for the project. I just want, there is no presentation, formal presentation. All I need is to sit with the group and they need to explain your technique to me. Okay? There is a report due which will be submitted later on. You can submit it 1 week after the discussion. Online, you don't have to be here physically. That report contains some, so those of you who are doing senior project, they already know this template. I have used the same template as senior project template, but have modified it, made it very simple. Small abstract, few lines, about 150 words maximum, which is about a small paragraph of 4 or 5 lines. I need the problem statement, what you want, what are you doing in that? Number 2, related work. This is something that I want you to do just to see what people have been doing around. We have an ABET requirement that says contemporary issues. The understanding of contemporary issues. So what people are doing now, this will help us in grading that aspect. All you have to do, go to the library, or if you have remote access to the library. Is anybody there? There is no class here right now, you think? Is there a class? So anyway, have you ever used IEEE Explorer? Okay, yeah, they have a class here. What I will do, I will explain how to do the related work in a lecture and record it and put it somewhere on the. Also, what are the design constraints? Algorithm detail. This is where I'm really. These 2 sections are where I'm really looking for your work. So just write about your program project, the program and algorithm in these 2. Other things are just cosmetic. 2, 4, and 5. That's what are important.
Okay.